Finding the pH of a strong acid simply required us to take the negative log of the hydronium ion concentration, which was equal to the initial amount of acid that we put into the system. But in order to solve for the pH of a weak acid, we need to set up an equilibrium problem and set that equal to the Ka for the acid. So we have here a generic dissociation equation for a weak acid. Notice that it's reversible, indicating that this doesn't go all the way to the right, and this indicates that we have an equilibrium problem that we need to set equal to the Ka for the acid. To find the pH for a weak acid, first we write the equation for the acid and use it as a guide to prepare an ice table. We'll discuss what that means in just a minute. We complete the ice table based on the information that was given initially, keeping in mind the stoichiometry for the reaction. We substitute the expressions for equilibrium concentrations into the K expression and determine the hydronium ion concentration from the calculated value of X and our ice table, and then we use that to calculate the pH as necessary.